Hello dear students, welcome back to Learn Physics. In today's video, we are continuing with our Newton's Laws of Motion chapter. Laws of motion, today we are going to consider about Newton's laws of motion. We know there are three laws of motion. First one gives us an idea about inertia, that is, every body continues in its state of rest or uniform motion unless compelled by an external force. If we are not giving an external force, it will be continuing in its state of rest or uniform motion. Second one is force acting on an object is directly proportional to the rate of change of momentum. F is proportional to dp by dt. And next, third one is force acting on A to B. Every action there is an equal and opposite reaction. So FAB will be equal to minus FBA. In that from second equation we know P equals mv. Therefore, while we are solving this, we will get an equation F equals ma. This is the equation of for the what is that? From second law, we are getting an equation for F equals ma. Now, in numerical part, how we will be working with this Newton's laws of motion? And use for that, first we are going to consider for some of the example questions we will be doing this how we can solve this kind of questions. Okay, so for that, first I am considering, see, blocks of masses 4 kilogram and 2 kilogram are placed side by side on smooth surface as shown in figure. Horizontal surface of a 2 Newton is applied on 4 kilogram block. Find the acceleration of each block. How to solve this one? So such kind of questions. Today in today's video we will be discussing about the blocks which is attached together or if it is attached with a string. Okay, such kind of questions we will be doing it today. So two blocks are there, masses 4 kilogram and 2 kilogram are placed side by side on a smooth horizontal surface. So we are keeping it together on a surface and a horizontal force of 20 Newton is applied on 4 kilogram block. So this block we are applying a force. In such kind of questions, first step is we need to choose a system. What is which system, the whole physical activity is happening on which system. So our system is here 4 kilogram and 3 kilogram masses and 20 Newton forces acting on this and it is placed on a smooth horizontal surface. This one together we are considering it as a system. So all this is system. Now in this system which and all kind of forces are acting? That forces we can draw that with the symbol, only with the direction we can represent. That is called a free body diagram. Starting of this chapter itself I told you how to do this free body diagram. So next we are moving to the free body diagram. So here a 4 kilogram mass is here and to this I am applying a 20 Newton force. So since I am applying a force here, the continuation will be acting on the other side, right? So a force will be acting on this 2 kilogram mass also a force will be acting, right? A reactional force will be acting on a force is continuing in this 2 kilogram force. When we are giving a 2 kilo force to this 2 kilogram object, it will be giving a reactional force, right? So here we can write 4 kilogram. This is the first object and first mass. Here a 20 Newton force is acting and this is 2 kilogram. Towards this 2 kilogram, normal reactional force will be acting on this 2 kilogram. Here usually mg will be acting downward direction and why is reactional forces acting in the upward direction, like that we will represent, right? Mg acting upward downward and reactional forces acting upward. See, these two are equal and opposite. There is no force which is, or there is no motion along y-axis. So no need to consider this y-axis direction, because r and mg is sigma fy is equal to 0, because it's not moving in the upward direction. Y-axis, it's no movement. So no need to consider that. So here the reactional force is happening to 2 kilogram, and the force is acting on 2 kilogram, and the reactional force from 2 kilogram will be acting on that 4 kilogram also. And because of this force, both are moving with an acceleration. Both the objects are together, right? So both are moving with an acceleration. This also moving with an acceleration a. Okay, this is the free body diagram. Now we will be considering the x-axis and y-axis. So total force acting on the x-axis is equal to 0 if it is in equilibrium. If it is not at equilibrium, total force will be equal to, what is the force, with which force it will be moving. We can equate that. If it is under equilibrium, last class we told sigma fx is equal to 0, sigma fy equals 0. Here it is not in equilibrium along the x-axis. So here we need to consider those conditions we need to consider over here. First, the acceleration of each block. See, both are kept to there's side, right, side by side. So here acceleration, what is the formula? Force acting on it divided by mass. What is the net force acting on the system? We are giving a 20 Newton force. So the force equals 20. What is the total mass acting on the system? Is 6 kilogram. So we will be getting it as 10 by 3 meter per second square. This is the acceleration. So for finding out the acceleration, net force acting on the system divided by total mass. This is the formula for finding out the acceleration of each block. Acceleration, if the system, if we are considering all the bodies as a system, a common acceleration will be there. That common acceleration, we can find it as total force or net force acting on the system divided by mass. Now we need to find out the normal reactional force between the forces, between the blocks. We need to find out the reactional force. For that, normal reaction means these two are the normal, any one reactional force you can find out, that will be same, because equal and opposite reactional forces are acting, right? So first I am considering for 4 kilogram mass. Which are the forces acting along the positive x direction and negative x direction? Positive x direction, see here 20 Newton force I am applying. So a reactional force is acting in the opposite direction. So what is the net force acting on the system? 20 minus normal reactional force. That is equal to mass into acceleration, 4a. Okay. So the same way if we are applying for the second one, 2 kilogram mass. So normal reactional force is acting in the positive direction. That is the only force acting. That will be equal to mass into acceleration, 2a. Okay. So here we know that acceleration, we already got it as 10 by 3. 2 into 10 by 3. So here answer will be 20 by 3 Newton. So if I am substituting n over here, n is equal to 20 minus 4a, 20 minus 4a, 20 minus 4 into 10 by 3. So 20 minus 40 by 3, so 60 minus 40 by 3, that is again we will be getting it as 20 by 3 Newton. So any one way you can find out the acceleration. The normal reaction. Clear, children? So while getting such kind of questions, first you need to decide the system. So which in the whole system we can consider as, the whole thing we can consider as a single system. In that system, what are the forces acting? That one we need to find out. Okay, clear, children? So next we are moving to the next question. See here. Yes. This is the second question. Three blocks of masses 2 kilogram, 3 kilogram, 2 kilogram and 1 kilogram are placed side by side on a smooth surface as shown in figure. A horizontal force of 12 Newton is applied on 3 kilogram block. Find the net force on 2 kilogram block. We need to find out the net force acting on the 2 kilogram block. Okay, so 2 kilogram block is this one. We need to find the force acting on the 2 kilogram block. Here first we need to consider our system. What is our system? A 3 kilogram mass, and then side to that 2 kilogram mass, then along with that 1 kilogram mass. This is placed on a smooth surface. We are applying a force of 12 Newton. A horizontal force of 12 Newton is applied on 3 kilogram block. We need to find the net force on 2 kilogram. Force, how we can find out? F is equal to mass into acceleration. What is the net force acting? See, 3 kilogram force will be acting of the force in the 3 kilogram to 3 kilogram. 12 Newton force is acting, and a reactional force will be given to 3 kilogram also. So that force we are getting for 3 kilogram, and an equal and opposite reactional force will be given over here. And this 3 kilogram will be giving a force to 1 kilogram, and that one, this is 2. This is giving a force to this 1 kilogram, and 1 kilogram will be giving an equal and opposite reactional force. So all the forces, all other forces are getting cancelled on 2 kilogram. Therefore, we can find out force as mass into acceleration. That only is required. Okay, because n positive, see, 2n negatives are there, both opposite sides. So that it will be getting cancelled. Only F equals ma will be acting. Okay, so here we need to find out acceleration. How can we find out the acceleration? Total force acting on the system. What is the net force acting on the system? 12 divided by total mass. What is the total mass? 3 plus 2 plus 1. So here it is 6. We are getting it as 2 meter per second square. Therefore, F equals mass into acceleration. Mass is, what is that? 2 kilogram. Acceleration also 2. Therefore, answer is 4 Newton. Clear, children? So, the all other normal reactional forces between the blocks will be cancelled. Net force on 2 kilogram is the resultant of all these forces. Okay. So in next question, in the arrangement shown in figure, the strings are light and inextensible. Then the strings are inextensible. The surface over which blocks are placed is smooth. Find the acceleration of each block and the tension in each string. So here in this diagram, we can see that a 4 kilogram mass is there. Here it is 2 kilogram and here it is 1 kilogram. We are applying a 14 Newton force. 14 Newton forces acting. Here 2 kilogram. This one is given 1 kilogram and this is 4 kilogram mass. Okay, so these are the forces. It is attached with string. They are not kept side by side. Okay, so if it is attached with the strings, now what is our system? The place including, that is the smooth surface, and 4 kilogram attached to that string is attached to it with towards the 2 kilogram mass, and again a string is attached to 1 kilogram mass, and force 14 Newton is acting. So this whole thing we can consider it as our system. So 4 kilogram and next is 2 kilogram and next is 1 kilogram, and here force is acting, 14 Newton force is acting. This whole thing is kept on a smooth horizontal surface. So this whole system, this is our system. In this we can draw our diagram, and it is the surface over which the blocks, the acceleration of each block. So it is moving with an acceleration. Now we can find out first acceleration. What is the formula to find out the acceleration? Force divided by mass. What is the total force acting on the system? 14 divided by total mass is 7. 4 plus 2 plus 1, 7. So it is 2 meter per second square. This is the acceleration. Now we are going to find out the tension in each string. There we found out that in the previous question and all we found out the normal reactional force, right? Here it is attached with the string. So what is the tension acting on it? So for each mass, first I am considering for 4 kilogram mass, what are the forces acting? See, one tension will be acting towards this 4 kilogram mass and 2 kilogram mass. What about this 2 kilogram mass? 2 kilogram will be giving a reactional force and here it will be a reactional force that will be getting cancelled. Now I need to consider for this 1 kilogram mass. 1 kilogram mass will be given. See, this from here a reactional force of another reactional force will be given by this 1 kilogram mass. Okay, so here the tension given by 4 kilogram to 2 kilogram, that one I am giving it as T1 and the tension given by 1 kilogram to 2 kilogram I am giving it as T2. Okay, so because these masses are different, so it won't be of same what is that same value, it won't be having. So here we are giving a force to 14 Newton force to 1 kilogram. So when we are pulling it up in the forward direction, this 1 kilogram will be applying a force on T2, right? It is giving a forward force. Because of that, we will be giving, this 2 will be giving a reactional force to this one, right? And this, what about this 2 kilogram? It will be giving a force to 4 kilogram and 4 will be giving a reactional force. So T1 and T2 are the forces, or we can give, this is the first force where it is acting, right? So we can draw it, this is T1 or T2, that is your wish. If you are considering this as T1, this as T2, any one way we can consider. So the forces acting on this 4 kilogram and 1 kilogram only we need to consider. Otherwise, if we are taking it for 2 kilogram, equal and opposite forces we will be taking it together. Right? So tension acting on each string. So first string between 4 and 2, the next is between 2 and 1. So first I am considering for the 1 kilogram force. Which are the forces acting? 14 Newton acting in the forward direction, that is positive. And T1 is acting in the opposite direction, minus T1. That will be equal to mass into acceleration. What is mass? 1. Acceleration is 2. So we will be getting it as T1 equals 14 minus 2, that is 12 Newton. Next I am considering for T2, that is for 4 kilogram mass. For 4 kilogram mass, see here what is the force which is acting on 4 kilogram mass? T2 is the force acting on the only force which is acting on the 4 kilogram mass, that is equal to mass into acceleration. 4 into acceleration is 2, that is equal to 8 Newton. Okay, clear children? This is about the two forces which is acting on if we are giving force on different blocks which are separated by a string. Okay, clear? So this is about the how we will be solving the problems relating to this Newton's laws of motion. And next day we will be coming with the problems related to the pulleys, and along with that some of the questions also left out over here, that one will be considering in the next class. So I hope today's video is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.